So in this video lecture, we are going to look at what are the basic property of the waves and how we can calculate the velocity from the seismic wave. So first, let's look at the characteristics of waves. So there are different characteristics of the properties of the waves. So the first thing is amplitude. So how the amplitude can be measured? So it can be measured based on this or peak amplitude from peak amplitude to the zero amplitude. So this is actually called the amplitude. So the maximum displacement associated with the particle motion that occur as a wave passes through the materials. And the second thing is wavelength, which is also known as lambda. So lambda or the wavelength can be measured from one cycle. So this is cycle starts from 0 and up to 0. So this is one cycle, which is lambda or the wavelength. So the distance between 2 points with the same phase or the similar displacement, either it's from positive crossing to positive crossing. The third thing is the period. The period is how many number of cycle per second. So the time taken for a waves to go through one cycle. So let's say how much time it takes from here to here. So that is called the period. So the frequency is another component. So the number of waves that passes a fixed point in a given amount of time is called the wave frequency. So the wave frequency can be measured by counting the number of crests, like the highest point of the waves that passes from the fixed point in 1 second or some other time period. Let's say if you have given 10 seconds and you have to calculate, so that based on that you can divide with the 10 second rather than 1 second. So the higher the number, the greater the frequency, and in the SI System International unit, the wave frequency is known or the represented as hertz, Hz, where 1 hertz is equal to the one wave passing a fixed point in a second. So over here you have the example. Let's say this is the static example over here. So this is actually the wavelength starts from here to here. So in this case, you can see, let's say this is 1 second. So this is in 1 second, you have only one cycle, but in this one you have one. So in this, you will consider as a high frequency. So in this, you have the short wavelength, high frequency, and high energy. But in this case, you have low frequency, low wavelength, and low energy. So here is some example in traveling waves. So you can see sometimes the waves can change the frequency based on different scenarios. So let's say if you are stacking these and these waves, so the output will change based on the shape, because this is high frequency and this is low frequency. So when we sum up, so you will have the different frequency in your data. So let's look at further characteristic of the wave. So let's say when we are dealing with the seismic wave, we often insert the repetition. One of the component is a frequency. So the number of wave cycle that occur in 1 second is equal to frequency. So frequency can be 1 over time. So over here, if you say this one is like 1 second and you have to count the number of cycles, so this is 1, 2, 3, and 4. So you can call it the frequency of this wave is 4. So now let's count with the time. So over here we have the exercise 1. So this is 1 second and this is 2 seconds. And now you have to count what is the amplitude of this wave. So you have to stop the video and you have to give the answer. So for the time being, I will just continue. So let's say if you have to find the amplitude of this wave, so this starts from 0 to this point, which is the peak amplitude. So this is 0.5. And the second question is that the number of cycle per second. So this is 1 second. How many cycle we have? 1 and 2 cycle. So it means this is or 2 cycle per second. And what is the frequency of the wave? So frequency of the wave is number of cycle per second is 2 hertz. So this is 2 cycle and 2 hertz as well. So over here, this is exercise 2. Now we calculate the wavelength. So the wavelength is actually from crest to crest or trough to trough. So from here to here. So let's say what is the wavelength? So it's 0.8. Very simple. So now the velocity of the waves, how from the wave component. So we have the component like frequency, wavelength. So from there we can calculate the velocity. So let's say the velocity v is the rate of change passes through the materials. And we know the velocity is equal to distance per time, which is meter per second or kilometer per hour. And also velocity can be determined if we know the frequency and the wavelength, because if we know the frequency and wavelength, then we know the velocity of the wave. So from this definition or from this formula, v is equal to f lambda, velocity can be defined based on the frequency and also the wavelength. So now what we can do, we can also find out these elements like the frequency and the lambda. So frequency is equal to cycle per time, and also the wavelength is equal to distance per cycle. So now we combine or we correlate this formulation from the Newton's law. So which is v is equal to f lambda. So if we put the only the parameters of this one, cycle per time and distance per cycle, so the cycle cancel. So we left with the distance per time, so which is equal to velocity. So now based on these two parameters, which is frequency, we got it from the previous wave, which is 2 Hz, and also the wavelength, which is 0.8 kilometer. So from these two things, we can calculate the velocity of this wave. So what will be the velocity? So we'll just multiply 2 Hz with 0.8 kilometer per cycle, so which is equal to 1.6 kilometer per second. So this is actually the velocity of these seismic waves. This slide is actually to present what is the wavefront and the ray. So the wavefront, which is shown over here, this is the wavefront and this is the ray part. So the wavefront is the locus of the points where the pulse has reached at a given time. So all the points on the wavefront have the same phase. I mean, on this part of this wave propagation, so the wavefront has the same phase. And the ray is actually the vector which shows the direction that the wave is traveling. So it's perpendicular to the wavefront. I mean, always this is perpendicular. Over here it's perpendicular, and also it is perpendicular. Okay, with that's all. Thank you so much, and I hope you have learned about the properties of the waves and how we can calculate the velocity from the seismic wave. So the main component is we have the frequency and also the wavelength. So from these two components, we can get the velocity of the subsurface. Because initially when you are doing the surveys, so from the seismic survey, normally we have only the information of the uh, frequency and the wavelength. So we know these two information, then we can calculate the velocity. Based on the velocity, we can know what is in the subsurface. Okay, that's all. Thank you so much and have a good day.